Okay, so you guys did hypothesis testing. In the last lesson, you learned what a null hypothesis on an alternative hypothesis was, when to reject, when to fail to reject the null hypothesis. And now we're going to focus on more what happens after you do that, so after you make that decision. So type 1 and type 2 errors can come up based on the decision you make. So you know that when conducting a hypothesis test, there are two possible decisions. So you can either reject the null hypothesis if your p-value is less than alpha, or you can fail to reject the null hypothesis if your p-value is greater than alpha. So you remember that hypothesis testing uses the data from the sample in order to make an inference about the population as a whole. So in most cases, we actually don't know if our inference is correct or incorrect. So what this really means is that we make a decision based on our data saying that our data is most likely correct or incorrect, but we don't actually know if our inference is true or not, most of the time. So first, when you reject the null hypothesis, there really could be a difference in the population. So that's what we say. That's our final decision. We say that there is a difference in the population because of our data. So that is the correct decision. That's what we say. Or there could be not a difference in the population, but our sample was different. So we say that our data was significant, but in real life, it's actually not significant. So that means an error was made. On the other hand, you can decide to fail to reject the null hypothesis. So you're actually saying that this data is not different, it's not significant. So you could be right and you could say the null hypothesis is true, there's no difference in the population. Or you could be wrong and there actually is a difference, but you failed to reject it and there is another error. So there's two errors that can be made. Really, you should only make one after you make your decision. So you either reject the null hypothesis or you fail to reject the null hypothesis. And there's two errors that you can make, which we call type 1 and type 2 errors. So type 1 error is when you reject the null hypothesis when the null hypothesis is really true. So again, that was that first one we went back. You say that there is something going on, but in reality, there actually isn't. Your data really isn't significant. Or your data is just significant that one time, but in reality, it's not. It was just a fluke. So we denote a type 1 error by alpha. And you don't want to get it mixed up with the alpha that we use to measure our p-value. Those are separate scenarios that we use it in. But here our alpha equals p times our type 1 error. So if we move on to a type 2 error, a type 2 error is the opposite. It's when you fail to reject the null hypothesis when the null hypothesis is really false. So you're saying that there isn't anything going on. Your data is not different than others, but in reality, it is. So you denote a type 2 error by beta, and beta equals p times your type 2 error. So here's a little chart to see, so you can see how your decision is related to reality. So a lot of times we don't know what is true. That's why we make these hypothesis tests. So it's a little difficult to explain and get a grasp of, but you really don't know reality. It's unknown. But these are the types of errors you could make based on your decision if you fail to reject or reject the null hypothesis. So we're going to go over some practice problems. Hopefully it'll make it a little more clear. So a man goes to a trial where he is tried for stealing from a store. The hypotheses tested are null is not guilty, and the alternative hypothesis is that he is guilty. So a type 1 error is committed here if we reject the null hypothesis when the null hypothesis is true. So that's the definition of a null hypothesis, or of a type 1 error actually. But if we put it in the context of this example, it means that the man actually did not steal from the store, but he is found guilty and punished for the crime that he didn't commit. So on the other hand, if there was a type 2 error, it would be if we fail to reject the null hypothesis when it is actually false. So in this case, it means that the man actually did steal from the store, but is found not guilty and isn't punished for a crime that he did commit. So you can see the two differences between the two here. And you can see that usually the reality is unknown, because if the reality was known, then you wouldn't make an error in the first place. But these are just the differences between type 1 and type 2 error. I think this example puts it in a good perspective. All right, so power. So power is the probability of rejecting the null hypothesis given that the null hypothesis is false. So it's, in other words, it's the probability of correctly rejecting the null hypothesis. So you can calculate power by taking 1 minus beta, and beta is the probability of committing a type 2 error, which is correctly rejecting or falsely rejecting the null hypothesis. So that's power, correctly rejecting the null hypothesis. Okay, so we kind of just went through a lot there, but I have a few review questions we're going to go over. You can just type your answer in the chat box once you get it, and I'll go over it in a couple minutes. A group of culinary arts students is comparing 2 methods for preparing asparagus, traditional steaming and a new frying method. They want to know if patrons of their school restaurant prefer their new frying method over the traditional steaming one. A sample of people are given asparagus prepared using each method and asked to select their preference. A statistical analysis is performed to determine if more than 50% of participants prefer the new frying method. So they give you the hypotheses here, and they just ask for which the following is true. Okay, so we're going to go over this one. I hope you had a chance to look over it. So it's asked which of the following is true. So we're just going to go through A, B, and C and just cross off each answer as we go. So A, this is a left-tailed test. So to determine this, we can go into our alternative hypothesis, and we can see that it says that P is greater than 0.50. So that is actually a right-tailed test, so that is false. Next, B, there is a type 1 error present. So if they have to make a decision in order to figure out if there's a type 1 error present, and they haven't decided yet. They're only at the hypothesis part, or the hypothesis forming part of their analysis, so we don't know if there's a type 1 error present yet. And then C, population proportion is being tested, so we know that this is true because P is our parameter for population proportion, and it's in our null and alternative hypotheses. Okay, so this is the same problem, but we have more data here now. So everything is the same except for the last sentence. It says, let's say p hat equals 0.75, and we get a p-value of 0.049. Which of the following is false? Okay, so the answer here is C. So it asks which of the following is false, so A and B are true. For A, this data is statistically significant because our p-value is less than 0.05. Since there's no other alpha given, we can assume that our alpha is 0.05 here. And then B, we should reject the null hypothesis. That is true as well, because if your p-value is less than your alpha, that means you should reject the null hypothesis. And then the opposite of that is failing to reject the null hypothesis, which we do not do here because our p-value is less than alpha. But if our p-value is greater than alpha, then we would fail to reject the null hypothesis. All right, in the last one, we say that we should reject the null hypothesis. Suppose we reject the null hypothesis, but actually the patrons of the school restaurant do not prefer the new frying method over the old frying method. Which of the following is true? All right, so our answer here is A. There is a type 1 error. So we can determine this because we say that we start off by rejecting the null hypothesis. So when we reject the null hypothesis, we say that there is something going on or our data is different than the others. But in reality, the patrons of the school restaurant do not prefer the new frying method. So they actually don't. So we say that our data is meaningful and that this means that they actually do prefer the method, but in reality they don't. So it's a false positive. We say there is something going on when there actually isn't. So that is a type 1 error. There would be a type 2 error present here if we said that we should not change the frying method. Everybody likes the old frying method. We do not want a new one. So they don't change it, but in reality, everybody did want a new one. So that would be an example of a type 2 error here. All right, this is the last question. So recalling the power function, if the power of a statistical test is increased, for example, by increasing the sample size, how does the probability of a type 2 error change? So here you can figure out the answer by kind of playing around with the function that I give. So you're asking if the power is increased, how does the probability of a type 2 error change? So really it's just if power increases, what happens to beta? So will it increase, decrease, or will it not change? Here, beta will decrease because if you say that, for example, if you say that your beta is 0.2, and you subtract 1 minus 0.2, then your power would be 0.8. And then if you decrease your beta, your power will increase because if you decrease it to 0.1, 1 minus 0.1 is 0.9. So your power only increases as your beta decreases.